So hello and welcome friends to our channel Intromech, and here we discuss about basic mechanical engineering concepts. So guys, you know that we have started a session regarding the solenoid valve selection criteria, and we have discussed many parameters based on which we should select the solenoid valve. Now this is just a summary of some of the parameters which we have discussed. Those who might not have got a chance to look for those videos can directly see this video. So without wasting time, let's get started. So we know the parameters which are very important: the principle of operation, the circuit function, the pipe diameter, and the thread types, the orifice, the kV value, that is the flow coefficient value, and the medium, and all other parameters. So in the today's session we will just take a quick overview of the first 5 parameters. So let's see how the solenoid valve selection is done. So before choosing any type of solenoid valve, it is very important that we should have a sufficient information about the application, right? So we must gather all the information about the application, that whether and where we are going to use the solenoid valve, what is the application in the circuit, and all those things. So that is very important. So this is some important information they have mentioned over here, and then we have the important parameters, right? So let's check out what are those parameters. So first one is the principle of operation, and there are different types of solenoid valves. So that is what exactly it is. Like, according to the type of solenoid valve, the principle of operation is different. The direct operated valves we have, then the semi-direct operated, and then the indirect, which are also called as pilot operated valves. So we should know that what are these types, what is their functionality, what is their principle of operation, because based on the application we have to go for these valves. So we should know the basics of these valves, right? So we will not go into much detail. This is just a quick overview. If you want details, please check out my previous sessions. I will drop a link over there, right? So we can see the direct operated valves can operate from the 0 bar. For the indirect operated valves, the pressure differential is must. So that is the important parameter, right? So that is the crux, that the direct operated valves can be operated with 0 bar, from 0 bar, but the indirect valves, the pilot operated valves, require a pressure differential. That is the must thing, right? Then the medium pressure, both make use of the medium pressure, that is the direct operated and semi-direct operated valves, right? And the semi-direct and then the indirect valves need a permanent pressure differential of around at least 0.5 bar for their proper operation. So this is a very important parameter as far as the operation of indirect operated valve is considered, right? So this is you can see the check if there is a permanent pressure differential over the valve of at least 0.5 bar. In this case, the indirect operated valve may be chosen, right? So this is the important thing we should keep in mind, right? Then we have a solenoid valve types link. Also you can check out the different types of solenoid valves, how they are like described, and how to read the types of solenoid valves. For that purpose, I have carried out a separate video in detail, and you can check out that video. I will drop a link in the comment section. Do check out that video so that you can get more information about the types of valves, right? So this is just how the solenoid valve work, and what are the types, and all those things are mentioned over here. So you can just go through this, the different 2x2 way valves, then what is normally closed valve, what is normally open valve, like, so all these things are mentioned over here. So you can just go through that. The indirect walls are also called as pilot operated wall. Right, so this is something about the principle of operation. You can read all these things. I will drop a link, and if you want these things in more detail, you can check out a separate session on the principle of operation. I will just drop a link into the comment section. Then the circuit function expresses which function a wall has in the circuit. So this is very important thing, that for which purpose you are using the solenoid wall, whether you are using the wall to operate a kind of cylinder or a wall, or that can be anything. So we should be clear that whether and where we are using the wall. On that basis we have different types, like 2x2 way, normally closed, normally open. So based on the application we have to select the wall. We cannot use the same wall for different applications, and again we can use different walls for the same application, right? So this is very important. We can carry out the same function with the help of 4x3 wall, and we can carry out the circuit function with the help of 5x3 way wall, 4x2 way wall. But the thing is, it is important that what is the function of that solenoid wall in the circuit. Then we have 3x2 way walls. So you should know what is the meaning of these ports and the symbols and all those things for the better understanding, and that's why I have carried out a separate session on the types, the pneumatics basics. So I will drop a link, and please check out that video. So this is about the circuit function, right? So these wall types, like normally open, diverting, universal, will have different functions in the circuit. So according to that you should select, because when you go for and select the wall from the catalog, it will ask for these options, like whether you want normally open, normally closed. Then you have pipe diameters, like what are the this indicates the ports of the solenoid wall, and they have usually female threads. So it indicates which type of pipes that can be attached, which kind of fittings that can be attached to the solenoid wall. So that is also important. Like you can see over here the thread sizes, then the piping sizes. So you can read this chart. So different sizes are given. So according to the wall size, this connection size varies. So according to that, the flow rate can also vary. So this is very important. You should check out that the wall has which type of port, what is the size of the port, because on that size your piping size will be dependent, and on the pipe size your flow rate will be dependent, right? So if you are having a small wall and a larger cylinder, definitely it will take a lot of time to supply the required amount of flow rate to the large cylinder. So this is very important. You should check out the fittings, the size of fittings of your solenoid wall, right? So you have PVC pipe, we have PVC fittings, then adapters, different adapters like nipples, reducers, sockets. These are just connection tools. Like if you have a longer line, so these adapters will be helpful, right? So this is regarding the pipe and thread sizes. Then the most important parameter is the orifice, the kV value, and the flow rate. So this is very important parameter, the flow coefficient of your solenoid wall, because that indicates how much flow can go through your solenoid wall. So that is nothing but the flow resistance of a solenoid wall is depending on the shape of your wall body, the diameter of the orifice of the wall, right? So the kV value is calculated through the mathematical expressions, and it is different for the different media, the gases, it will be different. For liquids it will be different again. In liquids it is dependent on different parameters. You can see the flow rate value is directly proportional to the flow coefficient kV, and that indicates the amount of water in meter cube per hour that passes through the wall at a pressure of 1 bar at 20 degrees Celsius. So the kV value is in metric units and the CV value is in imperial units. So that is the difference between kV and CV. You may come across the terms CV. So the CV and kV value both are same. That means both are flow coefficient values of the solenoid wall, and one is expressed in metric, the kV value, and the CV value is expressed in imperial units, right? So you can see the flow rate that is directly proportional to kV value. You can see the flow rate, the flow coefficient, differential pressure. You can see the Q value is directly proportional to the pressure drop dP, also the pressure differential. If the pressure differential higher, the flow rate will be higher. You can check out the examples given over here, how we can calculate the Q value, right? And so for application, it is important the solenoid has the right size and flow capacity, right? So for that purpose, the kV value plays a very important role. You can check out some flow principles over here. So the pressure, all the things are mentioned in detail. The flow coefficient, how it is calculated. Then we have a wall sizing calculator over there also. You can directly calculate the kV value. Then you can check out how these values are decided. Then you can check out an example so that you can get more idea. Then the correction factors for the gases. The gases have different properties as compared to the liquids, right? So here you can see the example. Then the gases, again, if you have a subsonic flow, supersonic flow, according to that the value changes, right? There are a lot of parameters which are involved in that. And then the CV value, as I mentioned, the CV value is, you can see it is 1.16 times the kV value, right? So both parameters are same, only difference is the units in which they are calculated. Both CV and kV are unitless quantities, but CV is calculated in, say, imperial units, and kV is calculated in metric units. So you can go through all these examples for better understanding, right? So you can check out this example. What is the minimum required kV value? If you know the pressure, inlet pressure, you know the pressure drop, the outlet pressure, and you know the flow rate. So what is the kV value required? So you can calculate this kV value, and you can check that the solenoid valve which you are selecting is having minimum kV value equal to this value. So this is very important. The flow rate, if you know the flow rate of the system, or say if you are using some pneumatic cylinder, and you know that this much amount of flow rate I require, then which solenoid valve should be selected. So you can go through this and you can check out the kV is 0.3. that means the kV value must be at least 0.3. so whenever you will select a solenoid valve, the kV value should be at least equal to 0.3. if it is greater than that, it's good, but it should not be lesser than that. It can create some problems. If you go for the higher value, the wall size will unnecessarily increase. So that's why it is important that you should know the kV value. Then the medium plays a very important role. We know that there are some liquids and gases having different properties, and that will definitely cause a problem if the material is not compatible with the wall body or the wall seal material. So different wall bodies materials are available like brass, steel, nylon, etc. Then different seal materials are available like FKM, EPDM, and all these materials have different properties, right? So this is important. The resistance of material for a complete list of media with compatible wall material. So you can just check out that list. So you should know that which material is say compatible with which wall material. So you should check that the wall selector is compatible with the media properties, and that's why this is very important. So this is it, guys. We have just summarized some of the major parameters like the principle of operation, circuit function, pipe diameter, orifice value, and the medium. In the upcoming session we will just summarize the remaining 5 parameters. So this is it for the today's session. So this is it, guys, for the today's session, and I hope you liked the video. So if you have any doubts, please do write into the comment section and we can discuss over there. Until then, stay home, stay happy. Thank you for the patient listening. Thank you.